Imagine a world where a tiny bee could detect a deadly disease, not by stinging, but by smelling. This isn't science fiction, it's the cutting edge of cancer research. Scientists are training bees, those masters of aroma, to identify lung cancer. Lung cancer is a formidable foe. It often hides silently until it's quite advanced. Early detection is key for successful treatment. Traditional methods like biopsies can be invasive and costly. Enter the bee, a beacon of hope in the fight against this deadly disease. These buzzing insects have an extraordinary sense of smell. Their tiny antennae are packed with olfactory receptors, far more sensitive than any man-made sensor. This allows them to detect minute traces of volatile organic compounds, VOCs. These VOCs act like a fingerprint, differing between healthy individuals and those with diseases like cancer. This innovative approach is still in its early stages. However, initial studies show great promise. Bees could revolutionize lung cancer diagnosis, making it faster, cheaper, and less stressful for patients. Bees navigate a world of scent. Flowers beckon with sweet perfumes, guiding bees towards nectar. Their survival depends on this acute sense of smell. Now, scientists are harnessing this olfactory superpower to detect lung cancer. The key lies in the VOCs emitted by cancerous cells. These microscopic signals are released into the breath. While humans can't detect them, bees can. Their sensitive antennae act like miniature chemical laboratories, rapidly analyzing the composition of the air. In a matter of seconds, a bee can distinguish between the breath of a healthy person and someone with lung cancer. It's like a sniffer dog at the airport, but instead of drugs, they're sniffing out disease. This incredible ability opens up a world of possibilities for early diagnosis. Imagine a future where a simple breath test, analyzed by bees, could catch lung cancer in its earliest stages. Training bees for this life-saving task is surprisingly straightforward. It leverages their natural instincts. Bees are incredibly quick learners, especially when it comes to associating scents with rewards. Scientists use a process called Pavlovian conditioning. They expose bees to the breath samples of patients with confirmed lung cancer. Simultaneously, they give the bees a sugary treat, a reward they can't resist. Through repetition, the bees learn to associate the specific VOCs present in the breath of cancer patients with the sweet reward. Soon, they begin to anticipate the treat whenever they encounter that particular scent. This conditioned response is the key. When presented with a breath sample, a trained bee will extend its proboscis, tongue, in anticipation of a reward, only if it detects the telltale scent of lung cancer. The potential benefits of using bees to detect lung cancer are significant. Firstly, it's non-invasive. No needles, no biopsies, just a simple breath sample. This makes it a far more appealing option for patients, especially those already anxious about their health. Secondly, it's remarkably cost-effective. Training bees is relatively inexpensive compared to the sophisticated equipment used in traditional diagnostic methods. This makes it a viable option for healthcare systems worldwide, particularly in developing countries with limited resources. Most importantly, bee-based detection offers the promise of early detection. Catching cancer in its initial stages dramatically increases the chances of successful treatment and survival. This innovative approach has the potential to revolutionize lung cancer diagnosis. It could transform the lives of millions by making early detection accessible, affordable, and less daunting. Section 5. The sting in the tail: challenges and considerations. While the prospect of bees detecting lung cancer is incredibly exciting, there are still hurdles to overcome. One challenge is standardization. Ensuring consistent and accurate results requires a standardized training protocol for the bees and meticulous handling of breath samples. Another consideration is the ethical treatment of the bees. Their welfare is paramount. Researchers must ensure the bees are treated humanely throughout the training and testing process. Finally, rigorous validation is crucial. Large-scale clinical trials are necessary to compare the accuracy of bee-based detection to existing diagnostic methods and to confirm its reliability in real-world settings. Section 6. A future buzzing with potential: research and beyond. Despite the challenges, the future of bee-based cancer detection is buzzing with potential. Research is ongoing to refine training protocols, improve accuracy, and explore its application in detecting other types of cancer. Scientists are also developing specialized devices to harness the bees' incredible sense of smell. These devices could analyze breath samples in real time, providing rapid and accurate results. The ultimate goal is to integrate this technology into routine healthcare settings, making early cancer detection accessible to all. Section 7. Ethical considerations. Bees at the forefront of medical ethics. The use of bees in medical diagnosis raises important ethical considerations. While bees are not typically considered sentient beings in the same way as mammals, their welfare must be paramount in any research or application. Careful attention must be paid to their housing, nutrition, and overall well-being. Training methods should be designed to be as stress-free as possible, utilizing positive reinforcement rather than any form of punishment. The scientific community must engage in open and transparent discussions about the ethical implications of using bees in this way, ensuring their welfare is always prioritized. Section 8. A world of possibilities beyond lung cancer. The success of bees in detecting lung cancer opens up a world of possibilities. Their incredible sense of smell could be harnessed to diagnose a wide range of diseases, each with its own unique VOC signature. Imagine bees detecting everything from infections and autoimmune disorders to Parkinson's disease and even malaria. The potential applications are vast and could revolutionize healthcare as we know it. This innovative approach highlights the extraordinary power of nature and the ingenious ways we can harness it to improve human health. The humble bee, once known for honey and pollination, could soon be recognized as a life-saving hero in the fight against disease.